All right, well, hello everybody. I'm Davor, this is Nick here. We're here working at Team Platform. It's 9 here, and today we're going to talk about how we transitioned from Terraform to reconcilers. But first I want to introduce our team a bit, what we do here at 9. We really have a big focus on Kubernetes here and DevOps. We have two different products. One's 9 managed GKE, which we built 2019 and now are in the operations there. And we built the 9 managed GKE product with Terraform, and we have now our new product, 9 Kubernetes engine, which launched I think today. Today the press release came out. There we built it with reconcilers. So we're really gonna see how we transitioned from one to the other. Obviously, we're hiring. Wanted to say that if you're interested in Golang and Kubernetes, hit us up afterwards. There are also other positions open at 9, like systems engineers and stuff like that. So let's talk about even before 2018, that was the landscape really for Team Platform. We had a managed OpenShift solution where we mainly used Puppet and Ansible, and we were looking for a new way to deploy our managed Kubernetes or managed cluster solution, because OpenShift, the prices were rising even before IBM bought Red Hat. And Google Cloud actually released the new zone, Europe West 6 here in Zurich, and that tipped a bit the scale for Google. That's why we chose GCP and GKE. And how we built our 9 managed GKE was really around Terraform. If you do not know Terraform, it's an infrastructure as code tool where you can define your configuration code. As you see down left, you just define what infrastructure you want to spawn. You say Terraform apply, and that spawns your infrastructure wherever. That is done through Terraform providers, for example, GCP provider, AWS provider, and that interacts with the target API. Yeah, so we really built around Terraform for this new product. Why? Because the Terraform provider for GCP was quite complete. It had everything that we needed, and also other providers like, for example, Helm, that we needed for the Kubernetes services we wanted to deploy for our own additional services. Yeah, so then we started writing a ton of modules, Terraform modules. Basically, a Terraform module is just a abstraction that groups together many different Terraform resources. It's really useful for packaging and reusing Terraform modules. And one important thing is, like, a module can call another module and abstract even further. So yeah, looking back, we now have 42 different Terraform modules for our GCP and GKE solution. And we had a bit of a trouble there, actually, because we wanted to deploy a new cluster and deploy more services on top of it. So we had to split up the Terraform apply into 3 different stages. So first of all, we have the GCP project, which basically creates the projects, enables all the APIs we need on GCP. This is done with a highly privileged account. Since you need to create projects, you need higher rights. And then in a second step, we create our GCP infra. This is, for example, a Kubernetes cluster, Cloud SQL databases. And then in the last step, we have K8s managed, which is basically our Kubernetes services that we deploy additionally. Yeah, so we created these 3 big modules that abstract smaller modules that we needed. Yeah, and how did we manage the versions really? So we had one big Terra file which basically defined all our production versions. Here, as you can see on top, we have the 3 big ones and all the smaller ones down there. And yeah, we had a ton of different kinds of repositories, all in Git defined. And yeah, how did we then create customer repositories? We really built the product around GitOps. So whenever a customer wanted a cluster, we bootstrapped a repository. There we defined our big 3 modules, as you guys saw there, and all the pipelines were running for the CI/CD, so we never ever deployed anything manually. And for example, if you open up a merge request, we had the Terraform plan running, and when we merged to master, to main, nowadays we say main, the Terraform apply ran. Yeah, and since we have a lot of different customers, we had to use also downstream pipelines, right? So if you deploy a change, you want to apply it to all the clusters. So yeah, it's done through downstream pipelines. And obviously, so theoretically, when you now change a module, let's say a Kubernetes service, you want to change a Helm chart. Theoretically, you should still check every single one of the plans because maybe a breaking change happens in one of the infra plans. For example, a node pool gets recreated, and there's also potential for customer downtime. Usually, we just checked wherever we changed something. For example, if I changed the Helm chart, I just checked the Kate's plan of a couple of customers. If it looked good, we merged. Until a junior engineer, who should not be named, and it was definitely not me, messed up the tags a bit and forced all the node pools to be recreated and a bit of a downtime. So we actually created a really cool tool called Terreview. This goes through all the clusters that we have and goes through all the stages and shows us what will change every merge request. So you have a nice little overview. That was a really, really cool tool, and I think this is also the biggest pro for Terraform, in my opinion, since it was quite clear when you merge something, what will happen. And I think still that is, to this day, the biggest pro that Terraform has over reconcilers, as you guys will see later on. Yeah.
Question.
Yeah, sure.
How did it work on a plan, or how did it output?
Yes. So you see, these are just Terraform plans for all the downstream modules. So for all the customer repositories, if you change, I don't know, just a module, it will print you out that, and then it's your decision if you want to merge or not. It's not going to block you, but it will show you a nice output.
So basically, merge together all the plan out.
Yes.
From different repositories and shows you the.
Exactly.
Okay.
Exactly.
It actually waits just right. I mean, every state basically sends something to the Terreview daemon, like the plan, and it will accumulate it and sum it up basically, and also to show that overview or to generate that overview. And once the last plan was sent, it will just create a comment on the original GitLab merge request, showing that up.
And it will also approve the merge request, and we said you need 2 approvers, one human one and one the platform bot, and so you had to at least run it once that way. But if you ran it once, made some more changes, you could theoretically still merge it. Obviously not recommended. Yeah, let's talk about some annoying stuff that we have with this setup. The Terraform state. Yeah, Our Terraform state is usually per customer in a GCS bucket, obviously not locally. Since we are working as a team, it would be kind of annoying. And sometimes it happens that we had to change the state manually. Yeah, provider updates or some upstream modules changes, and then it always gets annoying. And additionally, sometimes our GitLab runner crashes, and we had to delete the state manually, but that was more just an annoyance than an inconvenience. Yeah, one negative aspect. Another negative aspect of our setup, but not really about Terraform, is just we wrote a lot of end-to-end tests. So for each Terraform module, we did actually go apply it on a either testing cluster in the beginning, one big testing cluster. Then we switched actually to temporary clusters. So we spawn a cluster, test our Terraform modules, and then delete them again. But obviously, if a GitLab runner crashes, or maybe sometimes an end-to-end test fails weirdly, there's some leftover resources, and that costs quite a bit. Especially some GCP services are quite expensive. For example, the file store, the NFS managed NFS solution, I think the minimum is $200 a month, and so you have to monitor that a bit. Still to this day, we have that. And I think yesterday, like 10 clusters failed. I don't know for what reason, but yeah. Yeah, that was another inconvenience about our setup. But the biggest inconvenience was actually this. So we have our customer here, very happy guy, obviously, he's at 9. And he wants a database, right? He just wants a database, and how can he get it? Can he just create it himself? No, he cannot. Right? Instead, he needs to come to 9, open a ticket. We will then change that in his Terraform Git repo, add a resource or a module for, in our case, about a Cloud SQL database. We then wait till it's created, and then tell him, hey, you can get your DBs created, you can now use it. And that was really the biggest annoyance that we had. Actually, more the customers. Some suggested like, "Hey, can we create them ourselves?" And that is why we really had that in the back of the mind. If we ever create another product, we want to go a more self-service way and not be just an annoying middleman for the customers. So yeah. And obviously, the customer gets a bit annoyed, right? So,
yeah, that actually post it up. Right, was it a bird? Let's hope. Yeah, it was not only about Cloud SQL creation for customers where we didn't really provide any big advantage despite the fact that we just put it into a Git repo and wait, right? It's also like node pool changes on a Kubernetes cluster. If your customer comes and he wants a new node pool or he wants to change tains on a node pool or whatever, I mean, we were the ones who were doing that. And let's say the customer said, okay, I need to do that in the evening because, I mean, there are customers on that clusters. You can't just do it during the day. Although it's Kubernetes, but some customers still wanted to do it outside of the main window, so we need to do it in the evening. I mean, there's Canada for us. We have a Canadian office, right? So they can do it, but still, sometimes it's was not so cool. So we wanted to have the possibility of providing way more self-service than we have now, or which we still have now. And at the same time, a new project basically came up, which is NKE, with 9 Kubernetes engine. Management wants us to have Kubernetes clusters here at 9 in our data centers managed by us with all the same services which we already provide on GK, right? So we said, okay, what to do now? We could still use Terraform, same setup, 3 stages basically, or we could just go in a totally different way. And we decided to go into the totally different way. Yeah, we need some. I already said that, some improvements, but we still wanted to leverage the huge ecosystem of Terraform providers because, yeah, that's just big. I mean, if you want to change something I mean, there is for sure a Terraform provider for it. And we had written quite some Terraform code. Davor already said we have 42 modules. I mean, we were quite proficient actually in writing Terraform stuff. But not all of us, some, but not all of us, were very proficient in programming. And we were, like, at the same time, there was basically crossplane coming up. I don't know if you have heard of crossplane. It's basically, you use the Kubernetes API as your single source of truth for creating resources, and that will basically connect to any outside API and create resources there. So let's say you want to have a Cloud SQL database. You create that via a CRD on the Kubernetes cluster, then the reconciler runs. It detects, oh, you want to have a Cloud SQL database. It connects to Google, creates it there, and reports the status back. But for that, you need to write reconcilers, right? And you need to be proficient in programming. So yeah, we were a bit of not so sure about it. And we experimented a bit. We experimented with reconcilers and especially crossplane. Crossplane itself was very appealing, or is still. I mean, the guys over there are doing great work. But what they basically, the system of them is more like have a composition concept. So you have single resources, let's say like a Helm chart, and you have a VM which you can create somewhere. And if you want, for example, to create like a, I don't know, a VM with an additional service, you create a big bunch of YAML, which takes resources and packs them all into one in a new resource. But it's still YAML, right? So you don't have much of a, you can't really influence the logic behind all of it. The only thing you have is YAML and big code of YAML. So we were not really fans of that. We wanted to have full control over it with a normal programming language, and we definitely wanted to use Go. Yeah, back then we wanted also to use both the best of the both worlds. A team member of us developed the prototype for the Terraform provider. So the idea back then was you have a reconciler and you have single CRDs, like custom resources in Kubernetes, which just emulate your Terraform module, right? And all you pass are your variables, which you normally would pass to your Terraform module. Then the reconciler runs Terraform. It stores the state somewhere. Back then it was in a Kubernetes secret. I mean, you could have come up with something else. And so you could still use Terraform providers, like best of both worlds. Because back then there was no, what it's called, TerraJet, which is the new thing from crossplane, where you can basically generate code from existing Terraform code, that's very cool. But back then, I mean, 2 years ago or even more, I don't know, that didn't exist. Yeah, the prototype was developed, but to be honest, we were not really confident with that. I don't know. The guy who wrote it actually said, I'm not really sure if every corner case is really like implemented, and I'm not sure if we should go with that solution. So what to do? I mean, back then we were really like, we wanted to use Terraform providers, but we also want to have everything else, like all the logic. Yeah, and after some discussion, actually, we said, okay, we will just do it from scratch. So we'll write reconcilers. We will use parts of crossplane, but not really much of them. We will develop our own CRDs. So yeah, we started. It was totally different than Terraform approach. Do you guys all know what a reconciler actually is in Kubernetes? You know, okay, so you have custom resources, right? And a bunch of code, or like a piece of code runs, watches that specific resource for changes, for creation, for delete, and then it does things against an external API. Everything automatic, right? Yeah, that's a reconciler that you need to code. Also, Davor said we had, like, all the Terraform modules have been in different Git repositories. And we had that, what called Terrafile, right? The Terrafile solution. And what you've seen basically is the state of production, because every module was tagged with a version. If you do change on a module, you test it, and then you tag it, and then that module is fine, but it's still not used in production, like the new version. You still need to go into Terrafile and upgrade the version there, and then it will be used in production. So if you need to do changes, you always need to do multiple steps. And yeah, that was a bit annoying, to be honest. I mean, if you do multiple MRs per day, that was just, I don't know, we didn't want it anymore. So we actually thought about switching to a mono repository. And I'm not sure if everybody was a big fan, but in the end we did it. And now everything actually is in one big repository. And yeah, we're actually using Bazel to build all the stuff. And we're also using Argo CD to actually deploy our own infrastructure. For example, we have a service cluster, it's a Kubernetes cluster, where multiple services for customers will be deployed on. But to define that service cluster itself, we have the Go struct for that in our mono repository. And then, like we code it, and then Bazel is running, transforming that code into a YAML, and then Argo CD is reading that YAML and deploying it, basically. That's what it does. Bazel itself, yeah, I'm not a big fan of Bazel, to be honest, because it's so horribly complex, but if you're only a user, it's great. And I really need to say, I mean, we have guys in the team who can really do Bazel and understand all the bits and pieces of it, but I'm just a user, and for me, it just works so far. So I'm fine with it. And especially also a mono repository where you just have one Go mod file. So all your programs, all your reconcilers, what you write, are using the same dependencies. That's also very cool. And Bazel is also good in figuring out if you do a change in a certain code, in a certain reconciler, it will only run tests which actually depend on that reconciler. And all the other tests it will just use from cache. So that's quite convenient, actually. Yeah, so we came up with basically that structure. We have one Kubernetes cluster, it's actually a GKE cluster, which is our control cluster. And there, all the CRDs which we develop will be installed. So that's this self-service control plane, right? We developed CRDs like Kubernetes cluster, Argo CD, Ingress Nginx, and way other resources. For now, we have 64 CRDs developed. There's always like a reconciler watching that CRD and then doing stuff. So, for example, Argo CD, if you create an Argo CD CRD, it will create an Argo CD deployment on the service cluster. And as you actually need to specify that cluster, for example, in your Argo CD CRD, it will pre-configure that cluster in your Argo CD installation. So we can already use it just from then on. Yeah, and the cool thing is that's our single source of truth now. That's it. You can actually, Kubernetes is just providing the API for it. So you can control all the stuff with the UI, with kube control, or with any other resource which just has Kubernetes integration or can speak to Kubernetes API. And there you just see some APIs which we hit, just some of them with our reconciler code. So all the clusters which we actually set up here are done by a rancher. We have one rancher cluster which we talk to, and that rancher cluster will then create the Kubernetes cluster. Yeah. We had some things to solve, actually, as we decided to do everything from scratch. Obviously, we had some things to solve. Crossplane resources are not namespaced. Remember, I said we're using crossplane runtime, which is a library from crossplane for implementing reconcilers. Normally, you can use controller runtime. Crossplane runtime just provides you already with some helpers. For example, if you use controller runtime, you will have one function which will always be called. It's a reconcile function. And you need to do everything in that function, like checking, was your resource deleted? Does your resource need some updates or whatever? And in crossplane runtime, for example, that's already done in several distinct functions. So there's an observe function which will always gets called in the beginning, and there you basically find out, does my resource need an update? If it needs an update, you return, I need an update, and then an update function gets called. So there are multiple functions, and it just makes it easier. But crossplane resources are not namespaced, and we need namespaced resources. So crossplane runtime itself doesn't work with namespaced resources. So until now, we still have a fork of it, where we actually did some changes. Because upstream, they really decided to not go with namespaced resources. So that's where we are. We needed some dependencies between resources to solve. For example, you've seen Kubernetes cluster CRD, and for example, Argo CD, right? If I delete the Kubernetes cluster now, Argo CD is pointing to nowhere, and that's an issue. So Because in your reconciler, you always try to fetch the Kubernetes cluster, but it's not there anymore, and your Argo CD resource will now be in an error state, which is not so cool. So we came up with an usage system. So basically, you can't delete a cluster now if still something is pointing to it. That's also for other resources. That's a global resources or usage system, how we call it. Yeah, we also had some troubles with naming, but that's always the case in programming, I'd say, because it's not only about naming decisions like that's called, I don't know, bucket or whatever, object storage or however. It's also about the first issue. We still use Helm to install some like certain software to Kubernetes clusters, and we're using the Helm provider of crossplane for that, which obviously only uses not namespaced resources. So a Helm release is not namespaced. Our resources are namespaced. If they're not namespaced, they need a unique name. So we need to come from our resources to a unique name when creating a Helm release. That has to be solved. It was solved. Kubernetes resource reconciler. What we do is a lot of layering. You've seen the Kubernetes cluster CRD. I mean, you could write a reconciler code, and it could talk to Rancher, create the Rancher cluster. It could then additionally install software on top of it, create DNS records, and all of that, all in one. But we didn't want that. We wanted to have reusable components. So a Kubernetes cluster is actually creating an NKE cluster, and an NKE cluster is actually creating an RKE cluster, which is a Rancher cluster. So we have different layers and different steps in between, all backed by CRDs. And the Kubernetes resource reconciler is just usable to create a Kubernetes resource, like a CRD. Like one reconciler just creates another CRD on the same cluster. That's not possible for with crossplane runtime. It doesn't have that, so we had to come up with a reconciler which does that. Metrics, you all know. I mean, we need to know the error rate and stuff like that. And testing, that's always an issue. With the old Terraform setup, we had a really cool testing, to be honest, especially when talking about upgrades. You develop a module, like you do some changes, and in our end-to-end test pipeline, what it does, it installs the previous version of the module, and then checks out the code of the new version and tries to apply it to the same Terraform state. So that actually helped with Helm chart changes. I don't know if you ever encountered that, but if you, for example, change something in the Kubernetes service, which is immutable, and that only happens because of Helm chart changes, you can't roll out your new release. That's just not possible. And that happened, for example, in the Ingress Nginx chart, I think, back then. We've seen that because we deploy the old version first, then we try to apply the new version over the old version, and then it immediately says, I can do it or I can't. We don't have that anymore with reconcilers, to be honest. That's just too hard to do, I'd say. What we have now is just integration testing. We start a local control plane. As you've seen, we have the control cluster, and we have like child clusters, customer clusters, right? And if you test stuff, you need both locally on your laptop. You need a control plane where you create the CRD and the reconciler runs, and you need to emulate somehow the child cluster. There's env test for that from controller runtime. Very cool project. You can just test it to create resources, but it can't run any pods. So integration testing locally is really just for creation, deletion, checking if a resource is there, if it really matches what you wanted to create, stuff like that. And we have end-to-end tests. These are run after integration tests. They will spawn a real Rancher cluster. And then we will install everything on that, basically Rancher cluster, and do it real, like with pods and all that stuff. But we don't have you go from old reconciler version to new reconciler version anymore. Yeah. Next thing, separation of customer-defined data and data used for management. Let's say you have the Argo CD CRD, and the customer can like configure some parts of it, but it would not be cool for us if the customer could set the Argo CD version itself, because we can only provide some versions. I mean, it needs to be integrated in the whole ecosystem, right? So you have now separation. You have stuff which the customer can do in the CRD, but you still want to have some defaults and stuff which you can only control. And we basically did that via separate CRDs for configuration per type. That's our solution so far. It works really cool. It also allows us to update Rancher clusters, for example, or NKE clusters or Kubernetes clusters, however you call it, like per cluster. You just actually go into the namespace, you delete the configuration, then the reconciler will create a new configuration, and it will just take the most current template for it, which has the new version, and then the cluster will update itself. And so you can go from customer to customer and update clusters. Yeah, and quotas. For example, on a downstream cluster, on a child cluster, we allow to create public IPs. I mean, sometimes you need an FTP server in a pod. But we don't allow customers to create 20 or so of them. It needs to be there needs to be a quota on top of that, as also for block storage, for example. And that also needs to be developed. Now we track IPs on the self-service control plane, and we also, for example, track block storage on the control plane. Yeah, some stuff. To solve some statistics, actually, I ran that by a small little tool. Yeah, pure Go lines 103,000. Just still, you can see the Terraform modules thing. For example, all the Terraform code is from our Terraform modules, which we also moved into the monorepo. We're a big fan of that monorepo. All documentation is in, Terraform code is in, everything is actually in that one repo. There's some Bazel files and yeah, so just some stuff. Yeah, and we currently have 64 CRDs. That's actually growing because managed service now also took that up. Basically, we're currently in the making of a managed DB, basically, which you can just spawn like that, which will be created externally of the Kubernetes cluster and fully automatically configure for you. Demo time. Did I leave that in? Okay. Yeah, so I am currently on the control plane here, I think. You can see that, right? Is that enough? Okay. So yesterday I actually needed a cluster to debug an issue, so I decided to just reuse that cluster. It's called DNS test. That's a Kubernetes cluster. That's one of our CRDs. Please ignore the service cluster staging. That's just our service cluster in staging, as the name obviously implies. And as I told you, we have the Kubernetes cluster, and that Kubernetes cluster creates an NKE cluster, and that creates the RKE cluster, right? And you can always see it's in ready state and it's synced. That basically tells us, is the reconciler done with its work? You can also describe a Kubernetes cluster of DNS test. For example, there you will see the endpoint. That's the API server. You can see the node pools and stuff like that, and the location. And yeah, there's also that's something which crossplane runtime actually provides us. This is the connection secret, right? So the kubeconfig, basically, that will just be written to a secret in that namespace. And on the control cluster, a namespace is basically corresponding to, yeah, we call it like a project, I'd say. We also have organizations simulated, and then you will create or we get a namespace on the control cluster where you can create resources in, like Kubernetes clusters, databases in the future, and whatever. Yeah, so what you can see, we basically have a lot of CRDs. I don't have a Grafana instance for now. What I do have is some Prometheus instances, some of the service cluster staging, and the other one is 9 DNS test. We create one Prometheus instance just for us on every cluster, where we just collect a few metrics for, I mean, we need to provide some services, so we need to check if they are up. But they are normally, that's not a Prometheus instance used by the customer. If you want to have a Prometheus instance, you can just create it. So I obviously prepared that. So what we will create is a Grafana and the Prometheus for it. And as you can see, in the Grafana, I actually filter for data sources. So if I create a normal Grafana instance, it will automatically configure all Prometheuses which are in the same namespace, but I don't want it for now. I just want to have all the Prometheus instances with the used for demo label, which I also used here, right? Yeah, and in Prometheus I just set something like retention, time, and scrape interval. And what you can also see, the Prometheus basically points to a cluster. That's the DNS test cluster. And that's also where the usage system then kicks in. So if I do the create -f, what was it? Grafana. I don't have any permissions anymore. That's actually, yeah. As that is a GKE cluster, the self-service control plane cluster is a GKE cluster, and we, as a team, we only have read-only access. That's it. If we want to write something to a cluster, we wrote a small tool called Heimdall, which will get us higher privileges in a specific Google project, and it will also send a message to a Slack channel so that everybody of the team knows what you're doing. And that's what I need to do. And everybody in the team can then go to that Slack channel and, for example, press decline. But normally we don't do that because it would be annoying. Yeah, and it will be like revoked 1 hour after I did that automatically. So does it already work? Yeah. So we can have a Grafana instance. You can see it's ready is false. You need a bigger or sorry? Okay. Yeah. Grafana actually takes like 40 seconds or so to be installed on the service cluster. And there's also like the Prometheus instance, which should actually already be up. Yeah. Let's see. And afterwards, we can just basically log into Grafana, and it should work, and there should be a data source for our Prometheus. It's a bit. Now we need to wait, right? Yeah. And afterwards, I think, I don't know how much. What's about the time? I think we should get to an end, right? Let's hope that works. 40 seconds can be very long.
Yeah, but the watch timed out, so basically you have to check again.
Did it?
Because it didn't update.
Prometheus is up. And now it's up.
Yeah.
Okay. So if we do the describe Grafana demo, we can see successfully created stuff, and there's the URL, the demo. Hello, could you please paste that? That's bad. So DNS is not up yet. Grafana testline APIs. I'm sorry.
It's always DNS.
It's yeah. I mean, I prepared that before, right? And it might be that there's some negative caching now. Yeah.
Maybe change the name.
I could actually change the name. That's also true. Like we could say demo2 to be very, very creative. The Prometheus instance should work, so we can just do it. Ignore the error message that something already exists. But now we need to wait again. Yeah. Yeah. In the same time, we could actually, what I could show is, in the beginning I said just this one API, right? This is single source of truth. And that's not public yet, that's just staging. But we can also add an ingress via the UI, like demo, checking our DNS cluster, setting as OK, and save, right? And it will create now an Nginx ingress controller on that cluster. Just saying, right? It's not ready yet, but you can see you can control it via API. It's via CLI, via UI. It's just an API, and you have multiple methods to talk to it. Is there actually an API free? There is. Okay.
Check the Grafana.
No, it's no. I mean, sometimes you just need a bit of patience, right? Successfully, there's a demo, and that should actually just show a 404 because we don't have any ingresses yet on the child cluster. At least that's working. Yeah, I don't know if Grafana. No, I guess there's a different issue. Sorry?
Demo 2.
Oh. Okay. So there's at least, that's staging. That's why we use Let's Encrypt staging. And yeah, now you can go to Explore and see that there's a data source automatically created for your Prometheus, and I think there's also a dashboard which we create by default. Yeah, and that just shows some cluster values and also my lovely DNS pod, which I need to debug a customer issue. Yeah, that's it actually. Is there anything else on the slides? Oh, still to do. Yeah, we still have to do stuff. We still need more UI changes, as you have seen. I mean, there's Argo CD, for example, in the UI so far, and registry, like a Docker registry. But yeah, it needs to be more. The next step would be to import all the GKE clusters, which we currently set up with Terraform, into that self-service stack. That's actually a big task. But we hope we can do that. Develop more services, as always, and fully automate cluster updates. I told you we need to delete that Kubernetes cluster configuration per customer. I mean, that needs to be fully automated. And direct API access. I mean, we currently concentrated on the cockpit stuff, on the UI stuff, but the goal is actually to give the customer direct kube control access. So you get a kube config, you can use kube control just like I did, create Grafana, create Prometheus, or whatever. Questions? Cool. Yeah, I guess then I can say thank you very much for listening.